Hi everyone. So today's video is all about the mean value theorem. So this is another one of calculus's big huge theorems that we need to know and we need to be able to use, especially once we get into more FRQs for the AP exam. So one thing we have to remember is that mean in math just means average. So the mean value theorem actually compares the average rate of change with the instantaneous rate of change. So just as a reminder, if we talk about average rate of change, you guys should know that we're talking about regular old slope. And if we're talking about instantaneous rate of change, means we're looking at the slope of the tangent line, or in other words, we're looking at the derivative. So all we're going to be doing is comparing average rate of change with instantaneous rate of change, and we're going to be doing this on certain intervals. So let's talk about what the theorem actually says. So the conditions for the theorem, or really we're talking about the ifs, right? So if this stuff is true. So if f of x is continuous on the closed interval a to b. So remember, those brackets there mean that it's a closed interval, that the endpoints are included. And again, we call that a closed interval. So the function has to be continuous on the closed interval from a to b, and f of x also has to be differentiable but this time on the open interval from a to b, which means the endpoints are not included. So those are our two conditions. It must be continuous on the closed interval, differentiable on the open interval. The conclusions then, or the then, of the mean value theorem is that the average rate of change on the interval, so f of b minus f of a all over b minus a, must equal the instantaneous rate of change at some point. So it must equal f prime of c. So let's talk a little bit more about what that means. We just said f of b minus f of a over b minus a. That's our slope over the interval. From a to b, which we've found before anyway, right? It's the average rate of change over the interval. So we're saying that if it's continuous and differentiable, this average rate of change must equal the derivative at some point. So the derivative at some x value, and c has to be in between a and b, so c must be on the interval. All right, so let's talk about what we use the mean value theorem for. So we use the mean value theorem when we are trying to guarantee that a function has a specific slope value and we also use it when we're trying to locate the place where a function's average rate of change is the same as its instantaneous rate of change. I know this is kind of a lot. We're going to dive into some examples. Before we dive into the examples, we're going to talk a little bit more about what these conditions for the mean value theorem are so that we can make sure we understand them. So determine whether these functions do or do not satisfy the conditions of the mean value theorem. If they do not satisfy it, explain why not. So the thing we have to remember is there are two conditions for the mean value theorem. It must be continuous on a closed interval, and it must be differentiable on an open interval. So these are the two things that we want to check for each of these graphs. So looking at graph number 1, the first thing we want to check for is it continuous on the closed interval? So continuous. If we look, this is not continuous on that interval because there's an open circle right here. So there's a discontinuity at the end point. So it is not continuous at x equals a, which means it doesn't satisfy the conditions of the mean value theorem. Let's look at the second graph. So again, first thing we need to look at is it continuous on the closed interval? So is it continuous from A to B? And if we look, we start at A, we go to B. I can draw all of that without lifting up my pen, right? There's no holes, no jumps, no infinite discontinuities, nothing like that, which means yes, this is continuous on that closed interval, which is great. So the next thing we need to check is it differentiable on the closed interval from A to B? So remember, the things we need to check for differentiability are cusps, corners, vertical tangents, and discontinuities. Well, if we look right here, there's a cusp right there. So no, there's a cusp. Which means it's not differentiable. So this one does not satisfy MVT either. Let's take a look at the third graph, so C. Again, we're going to look for, is it continuous on the closed interval, A to B? So if we start at A, we can go to B, no problem. So yes, it's continuous. Question 2 says, or condition 2 says, is it differentiable on the open interval from A to B? And if we look, there's going to be a derivative everywhere on this interval. There's no cusps, no corners. There's no vertical tangents. It does get pretty big over here, but it's not going to actually be a vertical tangent anywhere. So this one is differentiable everywhere, which means this one does satisfy the conditions of the mean value theorem. Sorry, I don't know what I wanted to write there. I lost my train of thought. Yes, this satisfies the condition. The conditions of MVT. Sorry, I don't know how I lost my train of thought there. My bad, guys. All right, so let's look at this last graph so we can move on and actually do some examples here. So if we look, we need to know, is it continuous on the closed interval from A to B? And we can see clearly there's a vertical asymptote there. And so it is not continuous on this interval, which means it does not satisfy the mean value theorem. All right, let's look at some real examples now. All right, so question 2 says applying the mean value theorem to g of x, which is this function, on the interval from 0 to 2, guarantees that there exists some value c between 0 and 2 such that g prime of c equals what number? So this is off of an AP exam. We need to be able to understand what this actually means. So if we're looking at this question, they're asking what g prime of c actually is, which means we're looking at what's the guaranteed slope. What slope can we promise here? So remember, MVT has two conditions, right? We need to be continuous on the closed interval and differentiable on the open interval. So if we look, we've got this polynomial function, we've got a quadratic, which means, is it continuous on the interval? For sure, it is, because it's a parabola. And is it differentiable everywhere? We know that it's also differentiable everywhere, because there's no discontinuities, there's no cusps, corners, anything like that. So we know that we can apply the mean value theorem. Well, mean value theorem says that the derivative at some value c is going to have to equal the slope of the secant line on the interval. So that means we're going to be able to guarantee that it's equal to g of 2 minus g of 0 all over 2 minus 0. So this is the slope over the interval. So let's see, g of 2 just means plug in 2. So let's see if we go back to here. 2 squared is 4 times 3 is going to give me 12. Plus 2 times 2, which is 4, plus 1. So that's all g of 2. Minus g of 0, which is just going to be 1, all over 2. So let's see, we get 16 over 2. That means the slope over the interval is 8. All this is asking, it's not asking where this occurs. It's just asking what is the slope that we can promise. Well, we can promise that it's going to equal the slope over the interval, which is 8. All right, so let's look at question 3. So question 3 says we're given this function on this closed interval from 1 to 3. And so we're looking at what is the value of f prime that is guaranteed by the mean value theorem. So in other words, f prime that's guaranteed means what slope can you promise? What can you guarantee me is going to happen? Well, let's make sure that the mean value theorem can be applied first. So is it continuous? Well, it's a cubic function, so yeah, it's definitely continuous because it's a polynomial. Is it differentiable? Again, it's a cubic function, which is polynomial, so yeah, it's differentiable everywhere. So we can apply the mean value theorem. Well, we know if we're looking for the one that can be guaranteed, it means f prime of c is what we're looking for. So at some value c, the derivative has to equal the slope over the interval, which means this is going to be my a and b. So I'm going to do f of b minus f of a over b minus a, and I'm going to use the actual interval that I was given. So I'm going to do f of 3 minus f of 0 over 3 minus 0. And I'm going to figure out what these values are. So if I plug in 3, 1 minus 3 is negative 2. Negative 2 cubed is going to give me negative 8. Minus, if I plug in 0, 1 minus 0 is 1. 1 cubed is 1. All over 3. So that means I get a slope of negative 9 over 3. So it's a slope of negative 3. I can guarantee that somewhere on the interval from 0 to 3, the slope of the tangent line is going to be -3. Then let's look at part B. Part B says find the value of c that satisfies the conclusion of the mean value theorem. What this means, find the value of c that satisfies the condition, or the conclusion, excuse me, of the mean value theorem, means where does f prime of x equal -3? So we said because mean value theorem can be applied, we can guarantee that somewhere the slope is going to equal -3. This is asking, where does that occur? At what value does the slope equal -3? Well, we know then that what this means is that f prime of c is going to equal -3, and we're trying to find c. Well, in order to do that, I need to find f prime of x. So this is my function up here. So f prime of x, I'm going to need some chain rule here. I'm going to drop the 3, make it 1 minus x to the second power. And then chain rule means I need to multiply by -1, which means f prime of x is going to be -3 times 1 minus x squared. Well, we said we're guaranteeing that it must equal -3. So I'm going to take out f prime of x, and I'm going to say it has to equal -3. And I'm going to say that that must occur at some value c. So this is what I'm looking for. Now I just need to solve for c. So if I divide both sides by -3, I would get 1 equals 1 minus c to the second power. Then I can take the square root of both sides. So I would get plus or minus 1 equals 1 minus c. So from here I can actually write two equations. I can get 1 equals 1 minus c and -1 equals 1 minus c. So if I solve, let's see, subtract 1, I'd get 0 equals -c. Divide by -1, I'd get 0 equals c. And then if I subtract 1, I'd have -2 equals -c. Divide by -1, I'd get c equals 2. And the last thing we always have to do is double check our values here. So we need to find a value that's on the interval from a to b. So we know that our a value is 0 and our b value is 3. This c value that we're going to find has to fall in between 0 and 3. Well, when we look at these values that we got down here, we said one of the answers was 0. That doesn't work because it's an endpoint. 2, however, does fall between 0 and 3, so the answer here is just c equals 2. And what that means is if we were to find the slope of the tangent line at c equals 3 or x equals, 2, I know my numbers. If we were to find the slope of the tangent line at 2, it would equal -3, which is the same as the slope of the secant line through the actual interval. I know that's a lot. Hopefully you guys were able to follow along with me. Write down questions if you've got them, and we will be sure to talk in class. And we're going to do tons of practice on this, don't you worry. Thanks for watching.